Hi everyone, Mr. Fitri again, bringing you our second lesson focused on seafloor spreading. Now, last time we talked about Alfred Wegener's hypothesis of Pangaea, that all of the continents were once connected as one, and over the past 300 million years they have moved apart. So we're going to see how that happened today. So our objectives, and these are all pretty much condensed into just a lesson, and we're not going to look at them in much detail. First, what are mid-ocean ridges? What is seafloor spreading? And what happens at deep ocean trenches? Now, here we've got a picture of the world. We see the continents, but we also see these lines around the world. These lines differentiate the plates within the crust. All right? So you see these red lines and some dark blue lines. These are the plates that our continents and pieces of the earth sit on and which move over time. Couple vocab words here, all right? And these are, I think, words that you'll be able to use in not only science but also English and your education going forward. First of all, steep. Steep is rising or falling sharply. So you see that little goat on the wall there. That's a steep wall that it is climbing. It rises sharply. Next is valley, a low area of land between hills or mountains. That picture below the goat is of a valley. You see there is a low area of land, including a river, between the hills or mountains. A ridge is a long chain of hills or mountains. That bottom right corner is the ridge leading to the peak of Mount Everest. Now this was, I think, 2 or 3 years ago, when there were so many people climbing Mount Everest that they actually had like a traffic jam on Mount Everest, stuck on the ridge there. Not exactly a situation I would like to be in, if you ask me. The fourth vocab word is a trench. A trench is a small canyon. Now we're going to look at deep ocean trenches today, as you see in that picture there, where we've got the oceanic trench. Lastly, spread. Spread means to stretch out. Just like that grilled cheese sandwich there, we're stretching the cheese. Right? We're spreading it out. So looking first and foremost at these, at the seafloor spreading and mid-ocean ridges. Now, first of all, mid-ocean ridges are long chains of mountains that rise up from the ocean floor. And the process by which mid-ocean ridges continually add new material to the ocean floor. So you see in that picture there, what's occurring is you've got that molten material, that magma, rising up through the crust. And as it does, it pushes those pieces of the crust apart. Now, of course, these are under the water. So when the magma rises up to the surface, the water cools it, forming new rock, forming new material at the bottom of the ocean floor. Or I should say at the bottom of the ocean, on the ocean floor. Now this whole process is caused by the convection currents in the mantle. Remember, we talked about these a while ago, where you've got this hot material, the hot core and the mantle pushing up this hot material towards the surface. As this hot material rises, the cool material at the surface is pushed to the side and it begins to sink back down into the mantle. Remember, convection is the rising and falling of a fluid, all right, driven by the heat, either from, say, a stove, like boiling water, or from the core and the mantle of the earth. So, the process, like I said, is caused by the convection currents in the mantle, which slowly moves the crust of the earth, allowing new rock to be created and old rock to be destroyed. So along this ridge, along this mountain chain at the very bottom of the ocean, new molten material from inside of the earth rises, it erupts, and because the ocean is very cold, that molten material cools and hardens and forms a new strip of solid rock. So new rock is being created at these mid-ocean ridges, driven by seafloor spreading. Seafloor spreading being moved or pulled apart. Seafloor spreading adds more crust to the ocean floor, but at the same time, the older strips of rock are pushed or moved outward from either side of the ridge. So what happens to these older pieces of rock? Well, at deep ocean trenches, the oceanic crust bends downward over tens of millions of years. So the ocean floor sinks back into the mantle. These old, tens of millions of years old pieces of rock begin to sink back into the mantle at deep ocean trenches through a process called subduction. All right? I want you to think about it like a conveyor belt, like this little piece of sushi here, okay? So what's happening is the mantle and the crust, they're pushing this new material up. The new piece of sushi comes to the surface, and over millions of years it is pushed outward from the mid-ocean ridges, and eventually it gets sucked and pushed back down into the mantle. All right, where that rock is again used. It's melted and reused, and the process repeats again and again and again. Now, because of seafloor spreading, because of mid-ocean ridges, and because of subduction, the seafloor is renewed, right? It's made new every 200 million years. Now, if you remember back to our first unit, I said that the oceanic crust is made up of basalt, and the continental crust is made up of granite, primarily. It's because of this. The continental crust is very old. It's much older than the seafloor. That's why it's made up of granite. But the new seafloor is made up of basalt, an igneous rock that forms from the cooling of lava and magma. All right? And it's not being changed much. It's just being renewed through this conveyor belt-like process. So we've got all this stuff happening, all right? The convection currents in the mantle are pushing up molten material from the interior of the Earth. As this happens, that molten material is pushing up at these mid-ocean ridges, forming new rock. Now, because of this convection current, the crust is also being pushed outward. This is the process of seafloor spreading. The seafloor is being spread apart. Now, this older material, far from the mid-ocean ridges, is being pushed down. Okay, the convection cycle is pushing or pulling it back down into the mantle. And at these deep ocean trenches, that rock is being subducted. It's being pushed back down to be reused again. So again, it's this whole process repeating again and again and again. All right, which is how new rock is formed, and how continents and massive pieces of the crust are moved over hundreds of millions of years. So we'll build upon this next time. All right? Thank you.